Morning, everybody. All right, so just a quick couple of quick announcements. By the end of this week, the complete syllabus for the course, so that by complete syllabus I mean the dates of the quizzes and the tentative dates of the assignments should be on OnQ. So that should be up by the end of this week. Your first assignment should come out sometime this week. I'm just not sure when yet. Hopefully tomorrow. But we're having some coordination issues between the two sections. So as soon as we get those sorted out, we'll post that first assignment and you can get going on that. Other than that, I think it's just business as usual. Any questions so far in the course? Super. So we were talking about Java arrays. So you know that, so basically a Java array, it's a very primitive version of a Python list. Right, so here's an example of a Python method that computes the maximum value of an element in a list. Right? So we start out by assuming that the largest value is the first element in the list, and then we look at all the elements in the list using Python's for each loop. Right? So that's what it looks like in Python. There is a problem, well, there's a small problem with this method. Does anybody see what the small problem is with this method? Sorry, function. Anybody? It's actually on this line. Right there. Yes?
You never checked.
Oh, sorry. Okay, so we did have an answer at the front. What's the second answer?
You never check if like T is defined.
If T is defined.
Or like if T is a empty list.
Yeah, so they were both people had the right answer. So on this line here, we're assuming that T actually has at least one element in it, right? But a Python list doesn't have to have an element in it, right? So that list there might be empty, in which case, when you access that element in the list, you get Python will raise an error. Now, that might actually be exactly what you want to happen, right? You probably have to indicate that there's an error of some kind, right? You can't find the maximum element in an empty list. Whether or not you want to use Python's error that's raised here, or if you want to raise your own error, that's a design decision that you have to make, right? So there's a similar design decision when you do the Java version of the method, right? Again, it's basically the same thing, right? So I'm going to start out by assuming, right, the largest element in the list is the first element in the array, right? And now again, in Java, if the array is empty, that will result in what's called an exception in Java, right? So a Java exception is similar to a Python exception. Python calls it raising an exception or raising an error. Java calls it throwing an exception or throwing an error. Right? So at this point here, you have to decide, do I just want to use Java's exception that gets thrown here, or do I want to throw something else? Right? But we'll look at that a little bit later. Okay, so the corresponding for each loop in Java looks as follows, right? So it's for, and then the parentheses, right, round brackets, right? And then instead of elem in array, it's elem colon array, right? Where elem is a variable that you create, right? The type of the variable is the type of the element in the list, right? And so in other words, the for each loop loops over the elements of this array, right? So elem, each time through the loop, elem is just the loop variable corresponding to an element in ARR, right? So that loop there is exactly the same as that loop there. Right? And then the rest of the code remains the same. I just want to. Okay. So in many cases, you want the loop variable to correspond to the index of an element, right? And so you were also taught how to do a loop in Python that basically counts, right? From in this case 0 to the length of t minus 1. Right. So here I'm going to assume. So this one is going to return. Oh, this is still returning the maximum. Okay. So this one's going to this function. Sorry. Still, this one returns the maximum index. Pi equals. Oh, sorry. Def max. Sorry, my mistake. Return index. There we go. Okay. So this function here is supposed to return the maximum in. Wait a minute. Define the index of the maximum value in the list, right? And so often when you're looking for the max or the min or some other specific value, right, it's not the value that you're looking for, but rather it's the location of the value that you're looking for. Right? So here I want to find the index of the element. So if I want the index of the element, I could write a similar loop as on the previous slide and insert a separate counter variable, or you can just count using the loop variable. Right? So index, that's going to be the index of the largest element. Right? Again, we're going to start by assuming the largest element is the first element. And now, instead of looping over the elements in the list directly, right, I'm going to make a little, I'm going to make a little variable called I, or a loop variable called I. Right? This time I is going to range over the values 0, right, up to the length of the list minus 1. Right? And now I'm going to use list indexing to access the element in the list. Right? So I want to use list indexing here because I'm interested in the index of the element. That's the maximum value. And then you return the index at the end. Right? Now in Python, Python's nice because you can return both values at once. Right? So you can also do that in Python. Right? Which is super handy. Right? You put in your documentation for your function that you're returning both the index of the largest value and the largest value. Right? And now the person who's using the function gets both pieces of information, which in many cases you want both pieces of information. Right? So that's a neat feature of Python that unfortunately Java doesn't have. Okay, so if you want a counting style loop in Java, there is no for each loop that you can write, unfortunately. Right? So the way that the Python version works is that range is an object. Right? So while range is a class, when you make a range 0 length minus length of t, that makes a range object that knows how to count from 0, or sorry, whose values are 0, 1, 2, 3, 4, 5, up to the length of t minus 1. Right? Whoops, sorry. So that's actually a sequence. That thing range is actually a sequence in Python. Right? And so you can iterate over a sequence using a for each loop in Python. In Java, you don't have that. You don't have that luxury. Right? So there is no built-in range class that lets you loop over some range of values. You can make one, which we'll do later in the course. But it's inefficient in Java. Right? So instead, Java offers a separate second style of for loop, right? Which was the original style of for loop, actually. Right? So this was the only type of for loop that you could write up until Java version 5 of the language. Right? So this version of the loop is one that's, let's just look at it right here. Right? So it's still a for loop. Now I'm going to make a variable I, right? Just like I did here. Right? So I have an I in the Python loop. I have an I in the Java loop. Right? This time I is an index, so it's an int value in Java. Right? So I'm going to start by setting that value to 0. Right? So the first time this loop tries to run, right, the value of I will be 0. Right? Now the next, so then there's a semicolon. Right? After that, this is the condition that must be true for the loop to run. Right? So I want this loop to run as long as I is less than the, as long as the value of I is less than the length of the array. Right? So that's the loop termination condition. Semicolon. Right? That's called the loop update expression. Right? So at the end of the loop, what do I want to do to I? Well, I want to increase the value of I by 1. Right? So one more time. First time through the loop, right? I will be 0. Right? When does the loop run? Or when does the loop body run? Right? So the loop body runs as long as I is less than the length of the array. What happens at the end of the loop body after each iteration? We increase the value of I by 1. Right? When you make a variable like this inside the parentheses, right, that variable I is local, or sorry, the scope of that variable is the body of the for loop. Right? So on that line here, right, I is not available to you on that line there. Right? So I is only available to you inside the body of the loop. Right? The body of the loop is exactly the same as the body of the Python loop. Okay, so in Java, I have to return the index. I can't return both the index and the maximum value. Well, I can't return the index and the maximum value if I return an int. Right? If I return something else that can hold 2 values, then I can return both values. Right? But using an int, I can only return 1 value. Okay, any questions about that for loop? Anybody? All right. So I'm going to break that loop down now into parts just so that you, just to be clear about what everything is. So a quote unquote regular for loop, this is what I'm calling a regular for loop, right? This counting style loop. Right? So a regular for loop has four main parts. Right? There's the initialization expression, the termination condition, the update expression, and the loop body. Right? Surprisingly, 1, 2, and 3, these are all optional. So you don't have to have these in a for loop, which might seem weird, but it is possible to write a for loop that's missing one or two of those things. I don't know if you can write one that's missing all three. I guess you could. I guess if you're missing all three, it becomes an infinite loop. But I should try that. I'm not sure what happens if you miss all, if you're missing all three. The semicolons are always required. Okay, but the actual parts before and after the semicolons, those are all optional. Okay, so the initialization expression initializes the loop. Normally, it creates a variable that you want to use inside the loop. Right? It runs exactly once, right? Before the first time the loop runs. Right? So there, int I equals 0 makes a variable called I. The variable I usable inside the loop body. The termination expression has to be true for the loop to run the next iteration. Right? So the termination condition, right, the thing in red, is tested before every loop iteration. Right? So before the loop runs the very first time, that expression gets tested. If that expression is true, the loop body runs. If it's false, the loop body does not run. Right? When that expression becomes false, when that expression is tested and is false, you end up, you jump outside the loop, right? So you go past the loop body, and then the rest of your code continues. This is slightly misleading, what I wrote here. If it evaluates to false, then the loop stops iterating. So when it's tested and it's false, that's when the loop stops iterating. Okay, finally, the loop update expression is evaluated after each iteration of the loop. Right? So each time that loop body runs, at the very end of the loop body, that expression here gets evaluated. Right? So in this case, we add 1 to I. Right? So the termination condition and the update expression, right, they almost always involve the loop variable. Right? Not always, but almost always. Oops, sorry. Okay, so why are there two styles of loops? Right? Okay, so why are there two styles of loops? So the reason there's two styles of loops is because the for each loop, you can't always use that to solve a problem easily. Right? So for example, if inside the loop body you have to access more than one element of the array, right? So inside here somewhere, right? Inside the body, if I want to access more than one element of the array, then you probably want to use a regular for loop instead of a for each loop. Right? A for each loop, I can access one element of the array at a time. Right? With a for each loop, I can use the index. I can use the loop variable as an index, and then I can access multiple values of the loop at the same time. Right? So here's a little loop that tests: is that array sorted in increasing order? Right? So is the second element bigger than or equal to the first? Right? Is the third element bigger than or equal to the second, and so on and so on and so forth. Right? And so to write this method, well, one way to write this method is to look at pairs of elements. Right? First and second, second and third, third and fourth, fourth and fifth. Right? If I find any that are out of order, I know the answer is false. Right? So I start by assuming the list is sorted. Right? You could also, yes, you want to assume that the list is sorted. Right? And then you write your loop. Right? Now when I write my loop, I want to compare the second element to the first element. Right? So one way to write the loop is to start counting at index 1 instead of counting at index 0. Right? So I'm going to start at counting at index 1. Right? I want to count up to, but not including, the length of the array. So in other words, I want to go to the last element of the array. Right? And I want to look at the next element in the array each time through the loop. Right? So if I is my loop variable, and I want to compare the second to the first, then the third to the second, and then the fourth to the third, right? There's the element at the ith position, right? And there's the element at the previous position, right? So I minus 1, right? What's the smallest value of I minus 1? Well, I starts at 1, right? So that's 0, which is valid, right? If I had started at 0, right, I'd have to write the loop in a different way. Right? So if I started at 0, right? then I would have to go up to, but not including array length minus 1. Right? This would be array I, and this would be array I plus 1. Right? So what's the largest value of the index in that case? Well, it's I plus 1. The largest value here would be array length minus 2. Right? So array length minus 2 plus 1 is array length minus 1, which is the largest index in the array. Right? So in both Python and Java, whenever you're looping over the elements in a collection, right, it's very important that you make sure that your loop variable corresponds to a valid index. Right? So the way it's written here, can't start at 0 because that would become minus 1. Right? If you wrote it the other way, right, you'd have to go to array length. You'd have to go to less than array length minus 1 because that becomes I plus 1. Right? You can't go past array length minus 1. Okay, so if I find two elements that are out of order, right, so the next element is smaller than the previous element, then I know that the array is not sorted, right? So I set is sorted to false. And then after I look at all the elements in this case, right, so the way this is written, I look at all the elements, and I know that then by the end of the loop, right, I know that the list is not sorted, right? There's lots of ways to screw this up, right? Lots and lots and lots of ways, surprisingly. Even though it looks pretty simple, there's tons of ways to mess this up, right? So method, how to screw this up, you can do it this way. Else is sorted equals true, right? Okay, you really don't want to write that, right? Because what does this do? Right? So it goes through the array, right? It checks, it looks at a pair of adjacent elements, right? If they're out of order, it says is sorted to false, right? If they're not out of order, it says, whoa, there's a spelling mistake. Right? If they're not out of order, it says is sorted to true, but that's not what you want to do, right? As soon as you find one pair of elements that's out of order, the whole list is not sorted. I don't want the list to become sorted again. Right? So in this case, if your last two elements are in the correct order, this returns true. It ignores all the previous elements. Right? So don't do it this way. This is wrong. Right? Okay, so that's bad. Don't do it that way. Right? There's many other ways that you can mess up this loop. Right? And it's surprising. Right? Some of the ways that you can mess up the loop, right? Using the wrong starting value, using the wrong stopping value, using the wrong index here, using the wrong index here, right? If you know about break and continue, then if you use break and continue incorrectly, you can also mess up this loop, right? Okay, so when you, all right, so let's keep on going. So a picture of what this looks like, right? If I start out with an array of length 16, right? It's got some elements in it, so the inside the boxes, that's just the value of the array element, right? First time through the loop, right? I is 1, so I minus 1 is 0. Oh, sorry. I minus 1 is 0, right? I is 1. Compare the 12 and the 13, right? Is 13 bigger than 12? Is 13 less than 12? The answer is no. So we continue, right? So I goes up by 1, becomes 2, right? I minus 1 is 1. Compare these two values, right? Is the 14 less than the 13? The answer is no. Continue, right? And so on and so on. Right? The last iteration of the loop is when I is equal to 15, right? The length of the array minus 1. Compare those two values, right? Is the 27 less than 26? The answer is no, and so the answer is true in this case. Right? So there's a break statement. Python also has the break statement. I hope they showed it to you. Right? Break will break out of the loop, causing the program flow to go to the statement after the loop body. Right? So in this case, as soon as I find a pair of elements that are not in sorted order, I'm done. Right? The answer is false. So here I can break. Right? And break jumps out of the for loop that the break statement is in. Right? If the break statement is inside of a nested loop, so if there's another loop outside of here, it will break out of the inner loop. It doesn't break out of both loops in Java. All right, so if I find a pair of elements that are not in sorted order, the list is not sorted, I can stop, right? I don't have to look at the rest of the elements, right? And so when you break, you end up outside after the loop, and so now we can return false. So in this case here, right, when I find a pair of elements, right, so 15 and 99, where the next element is less than the previous element, we're done, right? So here we can stop iterating and return false. The other way to write this loop here is to get rid of isSorted and simply return false here, right? So you can return false from within the if statement or from within the loop body itself, right? And this is fine, right? If you do that, right, you have to ask yourself, can I really return false, right? So in other words, you have to ask yourself do I really know that the answer is true or false, depending on what you want to return, right? And so in this case, yeah, if I find two elements that are out of order, I can return false, right? If you're trying to do something like find the maximum element in a list, then you can't return from inside the loop body, right? You have to look at all the elements in the list before you know the maximum value, right? So the other way if you're going to use the return statement, then you can screw this up as follows. Return true. Oh, sorry, return false. Right, and again, you put in else. Return true. Oops. Right, so don't do that, right? You don't know that the answer is true, right? If you find two elements that are in sorted order, you still have to look at the rest of the elements. So you can't logically return true from inside this loop. Right? And so you have to watch out for that as well, right? So these are surprisingly common errors that you find when you're reading, when you're reviewing code. Okay, any questions so far about the counting style loop? Anybody? All right, carry on. Here's another example of where we're going to access more than one element of the array in each loop iteration, right? So here's reverse. I want to reverse the order of the elements in the array A, right? So in other words, I want to swap the first and last element. I want to swap the second and second last element. I want to swap the third and third last element, and so on and so forth. Right? And so if I'm going to do this, I need the index of the first element, and then I need the index of the last element, right? And then I need the index of the second element, and then the second last element. So that's going to be the index of the element at the front of the list. J will be the index of the element at the back of the list, right? So first time through the loop, the last element, right, the index of the last element is just the length minus 1, right? First time through the loop, the index of the first element is 0, right? And now I want to, in the loop body, swap the elements at indexes I and j. Right? How do you swap two values? Well, you make a temporary value. Right? Hopefully you know this by now. Right? So I make a temporary variable to hold one of the two values. Right? So I'm going to set that to AI. You could also set it to AJ. Right? Whatever value you remember here, you reassign on the next line. Right? So AI equals the value of AJ. Right? Now AJ equals the old value or the previous value of AI. Right? So I've swapped the two array elements. Right? Now, the next iteration through the loop, I need to move I to the right, I need to move j to the left. Right? So I need to move j to the front of towards the front of the list, I need to move I towards the back of the list. Right? So there's how I move I towards the back, and there's how I move j towards the front. Right? Subtract 1 from j, add 1 to I. Right? And away you go. So what's the loop termination condition? Right? So as soon as I and j pass one another, right? So if you imagine I is the index here, j is the index here, I'm just going to swap, right? And then as soon as they cross over, I'm done. Right? I don't need to swap any more elements. If you keep on going, you just unreverse the list. Right? So this is I is less than a length minus is less than a length, right? And then the loop ends up doing nothing. It reverses the list, and then it unreverses the list if you keep going. Right? So you have to swap when I and j pass one another. Right? So what does this look like in a picture? Right? First iteration through the loop, I is down here, right? J is over here. Swap those two values. right? So 27 goes to the front, 12 goes to the back, right? Next iteration, I goes up by 1, j comes down by 1, swap, right? I goes up by 1, j goes down by 1, swap, right? Now we reach this point here, right? So I is less than j, right? We're going to swap these two values, right? And then we're done, right? So j, because in the next iteration, j and I are going to switch values, right? And so now now you know that you're finished. Okay, so in that example, there are actually two loop variables, right? I got I and j, right? They have the same type in this particular example, right? So if you have a loop, or if you're writing a loop, your loop variables all have and you have multiple loop variables, they all have the same type, right? Then you are allowed to declare them all inside, you're allowed to declare and use them inside the parentheses, right? So here I can write this as int I equals 0, comma, j equals a length minus 1. Right? So in other words, I can bring the declaration of j into the loop itself. Right? You separate the two loop variables with a comma here. Right? You don't write int j here. Right? This declares I and j in the same statement. Right? So I is 0, j is length minus 1. Right? Here I is less than j still. Here I can update both variables in the same expression. Right? So I can increase I by 1 and I can decrease j by 1. Right? Again, use the comma, use the comma to separate the two sub-expressions. Okay. So this only works if the I and j have the exact same type, right? And they both have to have type int here. Right. Okay, if the loop body must access elements from 2 or more arrays, right? Now you have to use a regular style loop, right? So if there's 2 different arrays or 3 or 4 that you're trying to process inside the same loop, right? Then there's no way I can write a for each loop to process all of the array elements, right? For each only works over one of the arrays. So if I need to process more than one at the same time, more than one array at the same time, you almost certainly need a regular loop. So here I have an array A, right? An array B, right? I'm going to assume that A and B have the same length, but you really should check if they have the same length, right? So I'm going to assume they have the same length, and I want to compute the sum of their values, right? So I want A0 plus B0, A1 plus B1, A1 plus B, A2 plus B2, and so on and so on and so forth. And I want to return that array of sums, right? Okay, so it's pretty easy to write. You make your result array, right? So C is just the array that has the same length as A or B, right? As long as A and B have the same length. Write your for loop, right? Inside the for loop, just sum AI and BI, store the result in CI, and then at the end return C, right? There's no way that you can, is there a way to do this? There's no way to do this using a for each loop, right? You have to use a counting style loop here. Is that true? Yes, that's true, right? There's no way to write a for each loop over A or B or C and get this loop to work. I shouldn't say there's no way. It's software. There's always a way, but there's no convenient way to do this. Right. Okay, any questions so far? Okay, what about slicing a list? Right. So in Python, you were shown this, right? You were shown how to slice. Yes? Okay. So in Python, you can slice a list. That gives you a sublist of the original list. Super handy in a lot of cases. Right? So here I can slice my list T, right? Starting at index 2, right? So 0, 1, 2. So starting at the 12, right? Going up to, but not including index 5, right? So remember that when you slice, you don't include that index in the slice, right? So 2, 3, and then 4, right? So that slice is the list 12, 13, 14. Now in Java, you cannot slice an array, right? There's no built-in operator to slice an array, which is inconvenient if you're coming from Python, right? And you really want to slice an array. Right? So if you want to slice an array, you can't do it yourself. You can't do it without writing some code yourself, right? If you find yourself slicing arrays a lot, then you should write a method to do the slice, right? So we'll write a method called slice. It takes in an array, right? That's my starting index, right? So it's going to be the 2 in this case, right? That's going to be, stop is 1 past the last index in the slice, right? So 1 passed, right? And it's going to return an array of the same type as this, right? So if that's an int array, then the return value, the sub array is also an int array, right? Okay, so I'm going to need to pull out some elements of this array using these user supplied indexes, right? So before I start, I should check to make sure these indexes are actually valid, right? So in other words, I want to check, right? Start should be less than stop, right? Less than or equal to stop, right? Is that true? Yeah, less than or equal to stop. Right. Sorry, less than stop. Start should be greater than, less than or equal to. They can be equal, right? So if start is greater than stop, that's a problem, right? I can't do that slice. So I'll throw an exception, right? Is this the first exception I've shown you? I can't remember now. Yes? Okay, so in Java, if you want to indicate an error to the caller, then the standard mechanism for doing so is to throw what's called an exception. Right? So here, this thing called a legal argument exception, that's one class, one of many classes that describe or represent a type of exception. Right? So exceptions in Java are used to indicate exceptional events. Right? Something unusual has occurred. Right? Typically it's error conditions. Right? So there's lots and lots of different types of exceptions that you can choose from. Right? This is the one that we'll be using most often, I think, in the course. Right? But there's lots of these. Right? So there's this thing called a legal argument exception. Right? To create one of these objects, right, I use the keyword new. Right? So new illegal argument exception makes an illegal argument exception object. Right? Throw is the keyword that you use to throw the exception object. Right? That's just the terminology that Java uses to indicate an error. Right? When you want to indicate an error, throw an exception. Right? So you throw an exception object, and that's how it works in Java. Right? In Python, you would raise an error, right? Or raise value error. That would be the corresponding exception here. Right? You're allowed to put a message in. Right? So here I'm putting in the message start is greater than stop. Right? So that's indicating that the caller has called the method with the value of start. That's bigger than stop. Right? When the exception is thrown, whoever called slice, right, gets to handle that exception. Right? So if we reach this line of code here where we throw the exception, the method slice immediately stops running. Right? So right here, slice stops running. Control of the program goes back to whoever called slice. Right? When control goes back to the caller also gets this illegal argument exception object. Right? If the caller doesn't do anything special to handle the exception, then whoever called the caller now gets the exception object. Right? And then whoever called the caller who called the caller gets the exception object, and so on and so on and so on until you come all the way back to the main method. Right? If you get back to the main method and the main method doesn't handle the exception, then the program stops running. Right? And when this happens in Java, you get an output describing the sequence of method calls that resulted in the exception being thrown, and your program stops. Right? Here you want your program to stop, right? Because you can't do anything. The method slice can't finish running if the inputs are incorrect. Right? So exceptions typically, unhandled exceptions typically cause a program to stop running. Right? The output, the output to the console indicates which lines of code caused the errors to happen. Right? Now that's not the only condition you should check for. Right? So yes, start has to be less than or equal to stop, right? But there's lots of other conditions you have to check for as well. Right? Start has to be a valid index. So it has to be greater than or equal to 0, and it has to be less than the length of the array. Right? Stop has to either be a valid index or it has to be equal to the length of the array, right? Because it's one past the last element. Right? So there's actually multiple error conditions that you have to check for here. I can't fit them all on the slide, so they're not here. Right? Okay, so let's assume that the caller calls the method with the correct inputs. Right? Now we need to make the slice. Right? So how long is the slice? Well, I'll just go back here. Right? So that slice is 3 elements long, right? Which is just equal to 5 minus 2. Right? So the length of the resulting array is just stop minus start. Right? So I make a new array, right, whose length is stop minus start. And now I just fill in the elements of the array. Right? So here I'm going to start, so here my index I. These are going to be the indexes into ARR. Right? They're not the index into the slice. Right? So I've chosen to make those the indexes into ARR. Right? So I'm going to start at that, then start plus 1, then start plus 2, up to, but not including stop. Right? So I starts at start, ends before stop. Right? Each time I'm going to increase I by 1. Right? So in other words, I'm going to extract element I from the array, and now I want to put it back into slice. Right? But I have to remember that slice, its first element starts at 0, so I subtract start. Right? And then that fills in a slice 0, then slice 1, then slice 2, and so on, up to the length of the slice. Right? Finally, I can return the slice, and there's your slice in Java. Right? Okay, how do you call slice? Well, it's just a method somewhere. So you call it like any other method. Right? If slice is inside the class lecture4, right, then to call slice, you just write lecture4.slice. Right? Pass in the array that you want to slice, so that's t. Right? Pass in the indexes of the slice, right? And that returns a new array in which you can store your slice. Right? And away you go. Any questions? Okay. What about copying a list in Python? Right? So in Python, you can use a slice to copy a list. Right? So if I want to make a new copy of this list t, right? So in other words, if I want to make an independent list having references to the value 10, 11, 12, 13, and 14, and 15, right? I can just slice the list, right, with a colon. Right? And in Python, this makes a copy of the list. Right? So I could do the exact same thing in Java. Right? If I have this slice method kicking around, right, I can just slice the entire list. Right? So I can slice t, 0, 0, and then, t.length. Right? And that would work. Right? There's no colon, unfortunately, so I can't do that. Right? But arrays have this method called clone. So you don't have to slice a Java array to copy it. You can just clone it. Right? So I can write copy equals t.clone, round bracket, right? And that will make a new copy of the array t. So that'll make a copy, so a new array whose elements are equal to the elements in t. Right? What you don't want to write here, so in both in Python and in Java, what you don't want to write is the following. Copy equals t. Right, so do you remember what that does in Python? Does it actually make a copy? Anybody? Why doesn't it make a copy? Or what does it do instead? Yeah. Yeah, so copy and t, they're both names for the same list, right? They're both aliases for the same list. Right? So there's not a new list here, right? There's just another variable that happens to refer to the same list that t does. Right? And again, if they had told you that that t here was actually a reference to this list, then you could infer that copy is also a reference to that list there. Right? So you don't want to write that. That doesn't actually make a copy. Similarly, in Java, next slide. Right? In Java, you do not want to write the following. Star also. Oh, wait, sorry. There we go. Right? That doesn't work either, right? Also copy is not a copy of t, right? It's just another name for that array here, right? If you write also copy 0 equals 1, that element there changes to 1, right? So that doesn't make a new array, right? It just makes another variable that points to or refers to the same array that t does. Right? And it's because in Java, arrays are reference types, right? Just like lists are reference types in Python. Right? So don't write that if you actually need an independent copy. Right? If you need an independent copy, either call clone or write a loop make a new array, write a loop, copy the elements into the new array manually. All right, any questions about this particular lecture? So I've got like 10 minutes left, so I'm just going to jump into the next deck of slides, which is number 5, if you're following along. So this is char in string. All right, so in Java, string literal is just a sequence of characters between double quotes, right? So there, rub-a-dub-dub, that's a string literal, right? Each individual character in that literal, right? The R, the U, the B, right? Those are called chars in Java, right? In Python, the individual characters are actually strings, right? Here in Java, they're actually chars, right? So if I want to get the R, the first character in the string, right? I can't use the square brackets in Java, right? So in Java, string is not the same thing as a Python sequence, right? It's its own thing, right? So instead of square brackets, you have to call a method to get an individual character, right? And so the method you want to use is char at, right? And then that's an index, right? So the smallest possible value is 0. The largest possible value is the length of that string minus 1, right? The type of each individual letter in string is char, little c char, right? So it's primitive. Okay, if you have a char, if you want to write down a char literal for some reason, then you put it inside of single quotes, right? Now remember, a char is a single character, right? And can only be a single character, right? So that means inside single quotes, there's exactly one character always. Not always. There's almost always exactly one character, right? So here I can write char c equals single quotes a, so c is the character a, right? There I can write blank equals single quote space, single quote, right? And that's, so char is now the space character, right? If you try to write single quote, that's an error, right? There is no such thing as the empty char in Java, right? Just like there's no such thing as the empty int, right? Or the empty double, right? There's the value 0, but there's not an int, right? Or there's no int value in Java, right? So there's no char value in Java, right? You can't write an empty char, right? Okay, so char is weird. It's a bit strange, right? It's actually an integer value, right? And so a char value is just some integer number that gets mapped to some sort of printable, well, usually printable character, right? This mapping, we don't really care about how it's actually done, right? Formally, it's part of what's called Unicode, right? So it's just, remember, char is just a integer value, right? So inside the class big C character, right? Not big C char, big C character. Why it's different, I don't know, right? But it's big C character in Java, right? You can find the smallest char value and the largest char value, right? Numerically, those are 0 and 65535, right? Notice that there's this funny int inside of brackets here, right? So when you see a type inside of round brackets, right? That's what's called a cast in Java. Right? So what's happening here is that's actually a char value, right? Little c char, right? I'm going to try to convert that char value to an int value, right? So that's what the cast does, right? It tries to convert that value to that type, right? And if you do that, that will in fact print a 0, right? If you do the same thing here, right? So I take this integer value, right? Which is actually a char, and cast it to an int, then that will actually print out 65535, right? If you get rid of the casts, right? So if I strike the two ints inside the round brackets, right? Then Java will try to print the character corresponding to that value and the character corresponding to that value, right? And you'll get some unusual output, right? You won't get 0 and 65535, right? You'll get the character corresponding to the value 0. You'll get the character corresponding to 65535. Right? For the 0, you'll probably get nothing, or you'll get blank space. for the 65535, you'll probably get a funny looking square box, right? So Unicode, this standard here, tries to capture all printable single characters in all human languages, all written human languages, right? It also includes a bunch of other characters. So it has like some emojis and some other funny graphics and things like that. Right, okay, so here I've got the char value 65, right? So remember, chars are just ints, right? So if I print that character, it turns out that's the uppercase A, right? Don't memorize this, right? You can always look it up. You don't have to memorize this, right? Now remember, chars are just int values, or integer values, so I can do arithmetic with them if I want to, right? So for example, I can add 25 to 65, right? How many letters are there in the alphabet, English alphabet? Well, there's 26. So if I start at A and add 25 to it, I get to the capital Z, right? So you can also do arithmetic with char. What time is it? It's probably time to go, right? Let me do this slide and then we'll call it quits. All right, so you can do arithmetic with char, but the results are screwed up, right? They're unintuitive, especially when you try to add an int to a char, right? So let's take a look at this. So I'm going to start with the A. Right? I'm going to write C++. Okay? If I print C here, I'll get B. Right? So this is okay. This actually works. Right? If I write C plus equals 1, that's like writing C equals, that sort of like writing C equals C plus 1. Sort of. Right? This works. Right? If I print it, I'm going to get the capital C. Right? I can write C minus equals 1. That's sort of like C equals C minus 1. Right? That works. If I print it, I'll get a B. What doesn't work is if you write this for some bizarre reason, right? If I write C equals C plus 1, that doesn't work. It doesn't even compile, which is surprising, right? So if you try, if you try to write this down, what happens in Java is as follows, right? So when Java sees something plus something, right? The first thing that the compiler does is say, well, what's the type of C, right? The answer is char, right? What is the type of 1? Well, that's an int literal, so that's an int, right? What happens when I take a char plus an int? So it turns out in Java, the rule is you take the smaller type or the narrower type and convert it to the wider type, right? So the range of char is less than the range of int. So the char gets promoted to an int, right? So in other words, this ends up becoming the value 65, right? So I have an int plus an int, right? That's 66. Right? What is the type of the result? Well, it's int, right? Because int plus int always gives you int. Can I store an int in a char? The answer is no, because int is wider than char, right? And so that doesn't work. That's why you get a compiler error, right? And that's why I'm telling you here, right? If you try to do arithmetic with char, it's very unintuitive. It doesn't always work the way you want it to, right? This one's even weirder here. Just let me do the last example here, right? Suppose I take the char B. Right, so it's in the variable D. Can I write C plus D? Well, so it's char, right? C's char, D's char, right? So what I just told you is, right, that's a char and a char. So you would think, right, a char plus a char is a char in Java. It's not, right? So in Java, anything smaller than int gets promoted to int before you do arithmetic, right? That's just the way it works. Don't ask why. That's just how it works, right? That's how the language is defined, right? So char plus r becomes int plus int, right? What's the result of int plus int? Well, that's an int. Can you store an int in a char? The answer is no. Int is wider than char. I'm not allowed to store it automatically into an int. That doesn't work, right? So when you do arithmetic with char, right, plus plus works, plus equals, minus equals, those are fine, right? But when you try to actually do addition, subtraction, multiplication, right, then the results all become int, and you can't put those back in a char. Okay? So just keep that in mind if you ever need to do arithmetic with char, and I will see you in the next lecture.